Today's lesson's on absolute values, calculations and equations, but I want to run it a bit like a normal lesson. So Friday, you went through solving equations. So as a quick quiz, have a go at these. So what I want you to do is actually stop the video, whichever one of you's got it up on the screen, stop it, and then give everyone a chance to have a go at these. Now, hopefully you've gone through it. Well, hopefully at least you've answered it. And we'll go through it now quickly. So this is just an expand question. 5x minus 15 equals 2x minus 1. And then move the 2x over this side and you get 3x, and move the 15 over this side and you get 14, and then divide by 3. 14 over 3. As I said the other day, that's perfectly good, but you might have written it as, 4 3s are 12. So 4 2/3. But, it's actually best to have this one. This is practicing one of those ones with fractions in it. So times everything by 15. 15 times, 15 times, and times 15. And the 3 cancels, giving you 5. That gives you 25x minus 5 when you expand it. And 15 times 3, 45. X equals 150. Sorry, you've got to cancel the 5 and the 15, giving you 3, and then you go 3 times 3 and get 9. Just testing, seeing if you're awake. So now we've got 25x plus 9x, so what's that? 34x minus 5 equals 150. Add the 5 over the other side, divide by 34. So it's 155 over 34. Not very nice, but of course you can see I just made it up. And then the inequality or inequation, same thing at the bottom. It has 3 sides, 1, 2, 3. So we're just going to get the x on its own. So I'm going to take away 6 first. Then I'm going to, because that's minus 2 times, I'm going to divide by minus 2. Now there's a reason I'm putting that down as working, because not many of these questions actually happen where you have to take note of dividing by negative or times by negative, but it means you turn the sign around, or in this case, turn the signs around. So I'm going to divide by minus 2. I'm going to get positive 11 over 2. I'm going to have to turn this sign around, and then x, turn the sign around, negative 2, because minus 11 divided by 2 is 11 over 2, positive. 4 divided by minus 2 is minus 2, and that, of course, that just cancels there. So what I've actually got here is it says that x is less than, now I've done that, I just realised that the other day. X is less than 11 over 2, but also greater than minus 2. So I'll draw this on this number line, minus 2. 0. 11 over 2, that's 5.5-ish, so I'm going to go out here. And it's greater than minus 2, that way, and less than, reading it that way, less than 11 over 2 or 5.5. So it's in between here. And which one does it include? It includes 11 over 2, but doesn't include minus 2. All right, so on to what we're doing today, which is absolute value, calculations and equations. I'm not actually sure if you've talked about absolute values before. I think you have. I think you would have done it. So let's just do it fairly fast at the start. So the absolute value basically means the value, not the sign. So we're not worrying about, minus 3 being minus 3. And by the way, it's given these straight lines. So the absolute value of minus 3 is 3. because we don't care about the direction of it, we just want to know the size of it. It's the same as saying how far from the origin. So here's 0, here's the origin, here's a number line, not a number plane, and it's minus 3's here, and you can see that it's, of course, it's 3 units from the origin. So, of course, the absolute value of 3, which is out here, is also 3. So it's always positive. The absolute values are always positive. Could be 0, though. And there is a definition here, which we'll talk about in a minute. But the absolute value of x is either equal to x if x is positive or 0. In other words, the absolute value of 5 is 5, or the absolute value of 0 is 0. But if x is negative, so that says if x is negative, the absolute value of x equals minus x. So an example is the absolute value of minus 7 equals, using this rule, the absolute value of minus 7, because minus 7 is less than 0, is minus 7, which of course is plus 7. So this is sort of a formal definition, if you like, of what the absolute value means, but it ends up meaning the same thing as what's up here, that the absolute value is how far is it from the origin. Now, just in terms of calculations, which is what the first exercise is on, the absolute value of 5 minus 7 plus the absolute value of 3 is, just work this out first. Don't make that positive because it won't be right. Work out what that is first, and 5 minus 7 is minus 2, plus the absolute value of 3. Now the absolute value of minus 2 is 2, the absolute value of 3 is 3. So the absolute value of 5 minus 7 plus the absolute value of 3 is 5. And I notice in question 7, I think it is, that you're about to work on, it had it written a bit like this. It says, use the definition of the absolute value, this one, to write each expression another way. So this, we've got to write this another way. Okay, so this is how we write it, just like this, up the top. So this equals two things. X minus the absolute value of x minus 7 equals x minus 7 if x minus 7, I'm leaving a little bit of space there, is positive, or including 0. So I just left a space there because I don't want to write that here, because there's a nicer way of writing that. You add 7 to both sides, x is greater than or equal to 7. So if x is greater than or equal to 7, the absolute value of x minus 7 is x minus 7. In other words, 8, if you put in x equals 8, you get 8 minus 7 is 1. The absolute value of 1 is 8 minus 7, 1 is 1. That's the value of 1 is 1. Now, what about the negative one? What about the minus x? What is minus that thing? I'm just going to go over here. What is minus x minus 7? Well, it's like expanding it through the brackets. It's minus x plus 7. So I'm actually going to write that as 7 minus x. So absolute value of x minus 7 equals 7 minus x if x is less than 7. It obviously is the opposite of this one. So I want you to work on this 2.03, doing the left-hand side only. Yeah, you can either stop the video and do that now, but it's probably best just to keep the video playing and we'll deal with the equations. So we'll do the equations now, and then people can work at their own pace. Now, absolute value equations are probably a bit more predictable in a way, a bit nicer to work on. The absolute value of 3y minus 5 equals 7. To solve that equation, you get two solutions, because the absolute value, I'm going to write it over here, the absolute value of 7 is 7, fair enough. So, in other words, 3y minus 5 can equal 7. Or, it's actually an and because they both work. What else can be in here? Well, the absolute value of minus 7 is also 7. So if I put minus 7 in there, well, absolute value of minus 7 is 7. So this thing could be minus 7. And we just solve these two things separately. It's always the same as this. So now to solve this separately, add 5 to both sides. Divide by 3. You get y equals 4. Quick. What about this one? Add 5 to both sides. You get minus 2. So y equals minus 2/3. So we've got two answers. Now that's probably correct and done, but we might as well sub them in to check. So sub it in here. I'm going to sub y equals 4. Check y equals 4. You get the absolute value of 3 times 4 minus 5, which is 12 minus 5, the absolute value of, which is 7, which is right, because the absolute value of 7 is 7. So that's definitely correct. And let's check y equals minus 2/3. We'll sub it in to here. That is the value of 3 times minus 2/3 minus 5 is, the 3's cancel, so you get minus 2 minus 5, which is minus 7. The absolute value of minus 7 is 7, which is correct. It satisfies it. So in this case, they both work. And in fact, all of the equations, I think that you're going to see, they'll both work. There are some that don't, and that's a bit of an extension. If you want to push yourself and catch up with me tomorrow when I'm back for it, what equations will possibly not work? So think about what absolute value equations you might end up with an answer that won't work. Anyway, I want you to work on exercise 2.04, and in this case there's not very many, so do all of them.